So hello everyone and welcome back to the good stuff we have been doing. So today in this video we're going to try to find this beautiful integral in closed form. It says integral from 0 to pi over 4 of x squared cosine squared x dx. Now to begin with, of course, this is built for integration by part, because if you think about, say, u equals to tan x, then you get that du would be secant squared x dx, and when you transform this integral a bit, you get this is equal to integral from 0 to pi over 4 of x squared secant squared x dx. So you see that, okay, maybe this secant squared x could be related to tan x, and of course it can. So we could write this as, let's say, x squared times tan x from 0 to pi over 4. Remember, the reason we are doing this is because when you take derivative of tan, you get secant squared, and you subtract. Then here, when you do subtraction, you need to take derivative of 2x, which is going to be twice the integral from 0 to pi over 4 of x times tan of x dx. And then we evaluate the boundary term. If you put in pi over 4, tan pi over 4 will be 1, so this will be pi squared over 16. So you have a pi squared over 16 minus twice the integral from 0. Now for this case here, now tan x is going to be, I think it's going to be logarithm of cos x, right? Because if you take derivative of this, you will get cosine of x, and at the top you get sine of x, so you get tan x, but then you are getting minus here, so we should have to write this as negative 2 times, here you have a minus sine x, so you have a minus x times tan of x, not tan x, sorry, so you have a minus, let me keep different colors. So you have a minus x, so you have a logarithm of cosine of x. So this evaluates from 0 to pi over 4, and then you have to subtract this by twice. The reason we're subtracting this is that evidently this minus here would cancel out the minus from the integration by parts, so this minus is what we are bringing here. So we get integral from 0 to pi over 4, then you would have logarithm of cosine of x dx. Okay, now observe something here though, that you could, if you plug in x equals to pi over 4, you don't get log of 1, because cosine of pi over 4 is not 1, it is square root of 2 over 2, so you have a pi squared over 16 minus twice, so you have a negative, okay, this is going to be a plus, so you have a pi over 4, then you have a logarithm of let me just say logarithm of 1 over square root 2, okay, and then you have minus twice. Now we have to do the integral from 0 to pi over 4 of logarithm of cosine of x, but before we get back to this, let's first iron things out over here. Let's see, this is going to be pi squared over 16, so you have a minus pi over 4, okay, but first of all, this is negative 1/2 times this, so you get plus pi over 4, so you're going to get plus pi over 4 times the logarithm of 2. Okay, so this minus here, there should be a minus here, so this is supposed to be a minus pi over 4 log 2. Then you have a, now you could do this integral, this negative twice the integral from 0 to pi over 4 times the logarithm of cosine of x. You could do this using the Fourier series for logarithm of cosine of x and standard approach. Though in this case there is a simple trick we can apply that avoids the use of Fourier series. Okay, the simple trick is that you could, this 2 here, you just write this is going to be represented integral as, just say, pi squared over 16, then you have a minus pi over 4 log 2, then this will be minus this integral, write it twice, so you have integral from 0 to pi over 4 of logarithm of cosine of x dx, then you have plus integral from 0 to pi over 4 then you have a logarithm of still cosine of x, then dx as well. So this integral has been represented this way. Now for the second integral, observe that you could write cosine of x to be just sine of x divided by tan of x. And if you do that, because this is sine over cosine, so yes, so you could write it. So in that case, this is going to be pi squared over 16 minus pi over 4 log 2. So you write this as the integral from 0 to pi over 4 of the logarithm of cosine of x dx. Then this will be plus the integral from 0 to pi over 4 of the logarithm of sine of x dx. Then you have to subtract from this integral from 0 to pi over 4 of the logarithm of cosine of x dx. Okay, now we have a math rule here. So observe that we can still do something here though. Notice that we cannot combine these two together to get logarithm of sine x cosine of x, which is half of which is going to be half of a logarithm of sine 2x. So you can write it as pi squared over 16 minus pi over 4 log 2. Then you subtract, then you get the integral from 0 to pi over 4. So you get logarithm of half of sine of 2x dx. Now this part, this is g. This is defined to be negative g. So you have a minus of negative g. Now why this g is Catalan's constant. This integral, okay, this is tan, so this is tan of x. This integral is well known in this literature. It's just Catalan's constant g. If you use Fourier series for tan x, it's a very established integral. And of course, I have not made a video of it on my channel, but I'm going to make so, and I'm going to update the description here where you can go and enjoy yourself. It's a very nice integral. It's a very well-known standard. It's not difficult to prove, but the reason why we don't usually solve it when we are solving results is that you cannot solve it. You cannot solve it every day. Like for example, this simple integral 0 to pi over 2 of logarithm of sine x. This is the first integral you encounter. It's negative pi over 2 log 2. This is the first integral you encounter whenever you are learning any serious mathematical courses on integration. So, but no need for anybody to be doing it. In fact, it's a standard result. I don't even have to explain if I quote it. So that is what we do. So in this case, we do pi squared over 16. Then you have a minus pi over 4 log 2. Then you have a minus. Then in this case, you have to separate. You have a half of the integral from 0 to pi over 4 of no, not half. No, just minus the integral from 0 to pi over 4 of logarithm of 1 over 2 dx. Then you have minus the integral from 0 to pi over 4 of the logarithm of, so you have the logarithm of sine 2x dx, sine 2x dx, then plus minus g. The reason is minus g is because this is plus g, but this minus is going to make it minus g. So yes, I think everything is good and fine. So this is a minus sign. Now this is going to be a pi over 4. This is going to be a plus pi over 4 log 2. So this is going to be pi squared over 16 minus let's see. So here you will get to cancel out this. I think this cancels out with this. This is going to be minus pi over 4 log 2. Then you have a plus pi over 4 log 2. So they cancel out evidently. And then this case here, I think we have to take u to be 2x. If you do that, then du would be du over 2 would be dx, obviously. Then what others? If x is 0, u is 0, so you have a minus half times the integral from 0. If x is pi over 4, so you have a pi over 2. So but you have a logarithm of sine u du plus g. Okay, so yeah, when we proceed, you will have pi squared over 16. Then you have a minus, this is well known, this is half of pi over 2 log 2. So sorry, half of negative pi over 2 log 2. Then you have plus g. So you have pi squared over 16 minus pi over 4 log 2 plus g. So to confirm, let's check. Where am I getting the minus? Okay, this is going to be a plus sign here. So that is the correct solution. Okay, this is minus g rather. This is minus g. Yeah, this is minus g. So that is the correct solution. So thank you very much for watching, and please do subscribe to the channel. Bye and have a nice day.